We would like to find the distance from the point 4, -2, 6 to the coordinate planes and to the coordinate axis. What are the coordinate planes? Coordinate planes, as you see in the picture, one of them is XY plane. XY plane is the horizontal one, the green one, when z is equal to 0, as you see here. When z equals to 0. The other one is XZ plane. XZ plane is the blue one when y is equal to 0. And also ZY plane. So ZY plane is the red one when x is equal to 0. Okay, now I want to graph the point and see where the point is. So let me graph the point. Okay, this is z-axis, x-axis, and y-axis. As I say always, graph whatever that you can in the question, and also label the axis. Okay, so where is the point? It's 4. The x coordinate is 4, so let me count. 1, 2, 3, 4. Okay, just here. And then y is equal to -2, so this is the positive side of the y-axis, therefore it would be here. So it would be 1 and then 2, -2. So up to now I'm kind of like here, and now I need to pay attention to the height. The height z is 6. Actually, let me make this one a little bit better. Okay, there you go. And then I need to go up to 6. So 1, 2, 3, 4, 5, and then 6. So it would be somewhere like here. Okay, if I go up by 6 units. So this is the point, 4, -2, and then 6. So if this label is the positive x-axis, this one is positive y-axis, and this one is positive z-axis, the point is basically, let me change it, the point is basically in this quadrant, in here, in this octant, sorry, it's here. So now the distance from the xy plane, as you see, is just basically its height. The distance is always positive. Therefore, if I want to find the distance to the xy plane, it would be the absolute value of the third coordinate. Okay, so let me write it with this color. So it's absolute value of the third coordinate, which is 6. So now the distance from the point to the xz plane. Xz plane is this yellow one. If the point is right there, the distance would be, as you see here, the distance would be the absolute value of the y coordinate of the point, which would be the second coordinate. So it would be the absolute value of -2, which is 2, the distance to the xz plane. Now the distance to the yz plane. Yz plane is this one, the red one. So the point is right there. Now, if I want to find the distance from the point to the yz plane, I need to look at the first coordinate, okay, which would be the absolute value of the first coordinate, which is 4. If I want to explain from this shape, it's obvious. The distance from the point to the horizontal plane would be the height, which is 6, to xz plane in here, it would be the absolute value of the -2 because it goes along the y-axis, and then to the yz plane would be the absolute value of the first coordinate, would be this distance in here, which would be the absolute value of 4. Great. Now I would like to find the distance from the point to the coordinate axis. So the coordinate axis are these ones. The red line in here would be x-axis. then it would be y-axis, and then it would be z-axis. Okay, so let me write it in here. So x-axis, and if you see on the x-axis, y and z are 0, both of them. So y is equal to 0, and also z is equal to 0. Both of them are 0. On every point on the y-axis, is the green line. X is 0 and also z is 0. So x is 0 and z is 0. And any point on the z-axis. Z-axis would be the blue line in here. Every point in here, x and y coordinate of every point in here would be 0. So x is 0 and y is 0. Okay, now to find the distance from this point to the x-axis first. What is the closest point on the x-axis to this point? As you see, the closest point would be this one. Okay, so let me have the distance like this. So this point, which is 400, is the closest point to the point for -2 and 6. Now, looking at the formula, the distance formula between 2 points, let me actually recall that. So as I recall, distance from a point A, B, C to another point A, B, C is the distance that I'm going to show it by D would be the absolute value of the differences between their first coordinate square, differences between the second coordinate square, plus C minus capital C square. Okay, now I would like to find the distance between these 2 points. Okay, let me write with another color. So the D here would be the absolute value of 4 minus 4 square plus -2 minus 0 square plus 6 minus 0 square. Okay, I don't need that. So this would be what? It would be 0 plus 4 plus 36, which would be square root of 40. Okay, now the distance from the point to the y-axis. What is the closest point? The closest point would be this point. Okay, and here. So what is this point? This point doesn't have any zeros. Doesn't have any x value. So x value would be actually 0. And then -2, and then z is equal to 0 as well. Okay, so now I'm writing the distance formula between these 2 points, which would be what? 4 minus 0 square, -2 minus -2 square, plus 6 minus 0 square. So this would be 0. This is 16 plus 36, which would be square root of 52. Okay, now the last one. The last one is the distance from the point to the z-axis. The closest point to the given point would be this point in here, which is what? Which is the point 0, 0, and then 6. Why this is the closest one? Because it's along the cube. Okay, if I go like this, any point here, the distance would be much bigger. This is the right angle in here. If I choose another point in here, that makes a lot of the distance between the points. So this is the closest point. Okay, the same is true for everything in here. For example, as you see in here, I have a right triangle. Okay, and also in here I have a right angle. So let me write the last one. It would be square root of the distance between these 2 points, which would be 4 minus 0 squared, negative 2 minus 0 squared, and then plus 6 minus 6 squared, and the square root of all of them would be square root of 16 plus 4 plus 0, which would be square root of 20. Okay, so I guess that's it.